Welcome to the deep dive. Today, we're plunging into something pretty fundamental in app development, something that can get really messy, actually. Navigation.
Yeah, navigation. Specifically, how you can make it, well, smoother and just generally more robust, especially if you're working with SwiftUI.
Exactly. And we're looking at an article today that really digs into implementing the coordinator pattern, but specifically adapted for SwiftUI.
Right, taking that pattern, which has been super common in UIKit for ages, and figuring out how it fits into SwiftUI's whole declarative, state-driven thing.
So our mission for this deep dive is to really get to grips with how this pattern meshes with SwiftUI's tools like navigation stack, and crucially, what are the actual tangible benefits?
Yeah, what do you get out of it? We're talking cleaner views, better testability, and even tackling tricky stuff like deep linking, making that simpler.
Okay, let's unpack this then. If you, listening, have ever felt like you're wrestling with navigation state in SwiftUI, or maybe your views feel like they're doing too much work.
Handling presentation logic and navigation logic.
Right. Or if you've ever wondered, how do I open my app to a specific screen from a URL or maybe a push notification, then yeah, this deep dive is definitely for you.
It's all about finding a cleaner, more scalable way to, well, guide users through your app, more maintainable in the long run.
Okay, so let's start right at the beginning. This coordinator pattern. What is it exactly, and why all the fuss? Why has it been so popular, particularly, in iOS development?
Good question. So the article points out, like I said, it's been a big deal in UIKit for years. And the core problem it solves is that views or view controllers in UIKit land tend to know way too much about the app's overall structure.
Ah, okay, like this button knows it needs to push that specific next screen?
Exactly. They get tightly coupled. The coordinator pattern basically says, hold on, let's pull all that navigational decision-making out, centralize it.
So instead of, say, a button in view A directly pushing view B, the button just signals, hey, I was tapped. And then something else, the coordinator decides, okay, a tap on that button in view A means we should now show view B.
Precisely. The coordinator becomes the traffic cop for navigation. The view just reports what happened, like a user interaction, and the coordinator figures out the where to next part.
Right. And this is where it gets really interesting for developers, as the article highlights. It's not just about tidiness, is it?
No, not at all. The benefits are pretty significant. When you pull that navigation logic out, your views suddenly become much more reusable.
Because they don't care where they sit in the overall flow.
Exactly. They just care about displaying their data and handling their own local interactions. Makes them simpler components.
And testability must get a huge boost, too.
Oh, massively. You can unit test your coordinator's logic. Like, does it correctly decide to go to screen C when action X happens in state Y? You can test that flow logic without needing slow, complex UI tests just for navigation paths.
Plus cleaner views, right. They stick to their main job. UI presentation. Single responsibility.
Yep. And maintenance gets simpler. If you need to change a navigation flow, maybe button A now goes to view Z instead of B, you change it in one spot, the coordinator. You're not hunting through view code.
Okay, that makes a ton of sense for UIKit, which is, more imperative, do this than do that. But SwiftUI, it's declarative. It's all about state driving the UI. How does this coordinator idea, which sounds kind of like flow control, fit into that world?
Yeah, that's the key adaptation the article explores. You don't have the coordinator directly pushing view controllers anymore. Instead, it hooks into SwiftUI's own navigation system.
You mean like navigation stack?
Exactly. Navigation stack and its partner, navigation path. The stack shows views based on what's in the path.
So the coordinator's job shifts. It becomes the manager of what goes into that navigation path.
You got it. The coordinator owns and manipulates the navigation path. It becomes the source of truth for the navigation state. The article shows you need a couple of main things for this. First, a way to define your destinations.
Like what screens can actually be navigated to.
Right. And enum is perfect for this. The article uses a page enum with cases like .home or, importantly, .detail, which carries data. This makes your navigation strongly typed.
Nice. Okay, so you have the possible pages defined. Then you need the coordinator itself.
Yep, the app coordinator class. And crucially, in modern SwiftUI, you make this class add observable.
Ah, because the navigation path it holds needs to be published, so changes automatically update the UI.
Precisely. The coordinator holds this navigation path, maybe as an @published property inside the @observable class. And any change it makes to that path, adding or removing pages, SwiftUI sees it and updates the navigation stack.
Okay, so the coordinator holds the path. How does it actually, change the path? How does a button tap translate into navigation?
Well, the coordinator exposes simple intention-revealing functions. Like the article shows a show detail function.
Right.
And all that function does internally is path.append, page.detail, course does, of course. Just adds the detail page definition to the path.
In going back.
A go back function that just calls path.removeLast. Simple. The article also mentions a go to root possibility, which would just clear the path completely by calling path.removeAll, though they didn't need it in their example.
Okay, that's pretty neat. Centralizing the path manipulation. But wait, the navigation stack needs actual SwiftUI views to display for each page on the path. How does the coordinator bridge that gap between the page enum case and, say, a home view or a detail view?
Ah, good point. That's another job for the coordinator. It typically has a function, maybe called buildPage, that takes a page value and returns the correct SwiftUI view for it.
Like a factory?
Kind of, yeah. And the article shows using the @ViewBuilder attribute on this build function. That's super useful because it lets you easily use if statements or switch statements inside the function to return different views based on the page case.
So switch page, case.home, return home view, case.detail at course.return detail view kind of thing.
Exactly that. The coordinator knows how to build the view for any given page destination.
All right, so the coordinator holds the path, knows how to change it, and knows how to build the views. How do the views themselves, like a home view listing courses, actually trigger these actions in the coordinator?
That's the final connection. The coordinator instance needs to be accessible to the views that need to trigger navigation. A really clean SwiftUI way to do this, shown in the article, is using the environment.
Ah, like creating a custom environment key.
Yep. You define something like coordinator key and inject your app coordinator instance into the environment, usually near the top of your view hierarchy.
So then a button inside home view
Can just read the coordinator from the environment using @environment.coordinator, var coordinator, and then in its action, call coordinator.showDetail, the selected course.
and the view itself doesn't know how that detail view is shown, just that it needs to be shown with this course data.
Precisely. Decoupled.
And this all comes together in some kind of root view.
All right. The article calls it coordinator main view. This view is where you actually create the app coordinator instance, often as a state object or just at state if using @observable, and it's where you put the navigation stack.
And you bind the navigation stack's path parameter directly to the coordinator's path property.
Exactly. Navigation stack path.coordinator.path. Then, inside the stack, you use the .navigation destination for page.self modifier.
Ah, okay. And that modifier watches the path.
Yeah. Whenever a page value appears on the path, that modifier's closure gets called with the page value. And what does it do inside that closure? It calls coordinator.build, page.page, to get the actual view to display.
Gotcha. So the stack sees a page.detail on the path. The modifier calls coordinator.build with that page, which returns a detail view, and the stack displays it. It connects everything.
Perfectly put. The article uses some sample course data like background timer app in SwiftUI or mastering widget kit to show this flow in action. Tapping a course in the list adds page.detail to the path, triggering the navigation destination and the coordinator's build function.
Okay, that really clarifies the internal navigation. It sounds clean, keeps the views focused, but what about deep linking? That always feels like a separate challenge. Opening the app from a URL, maybe myapp.products123, straight to a specific screen.
Right, and this is where the coordinator pattern really pays off, I think, because you've already centralized navigation control.
Adding deep linking becomes much less of a hack.
Exactly, it slots right in. The core idea is a deep link is just another way to tell the coordinator to change the navigation path.
Oh, okay, so you don't need a whole separate mechanism.
Not really. The article lays out the steps. First, you got to tell your app it can handle a custom URL scheme. That's an Xcode project setting. They use DevTechie as their example scheme.
So links like devtechie.course.id XYZ will now open the app.
Correct. Then, when the app opens, because of such a URL, you need to catch that URL. SwiftUI has a modifier for this, .onOpenURL.
And you'd put that on your main view, the coordinator main view.
Usually, yeah. That modifier gives you the incoming URL. The article shows passing this URL straight to a new method on the app coordinator, maybe called handle deep link.
Makes sense. Keep the logic in the coordinator. And inside handle deep link.
You parse the URL, check the scheme, DevTechie, check the host, pull out the query parameters like the id.
Right. Get that course ID.
Yeah, and the article mentions a practical tip here. They changed their course.id from a UUID to a string just to make it easier to match the ID coming from the URL query parameter.
Good point. Once you have the ID and find the matching course object from your data, what then?
Here's the magic. The coordinator just does the exact same thing it would do if the user tapped on that course in a list. It calls path.append, page.detail.
Wow. Seriously. It just appends to the path, the same way internal navigation does.
Yep. The source of the navigation request is different, a URL instead of a tab, but the mechanism is identical. Modify this shared navigation path.
That is surprisingly elegant. The coordinator doesn't care why it needs to show the detail view, just that it needs to.
Exactly. It unifies internal and external navigation triggers through the single navigation path. The coordinator listens for taps via environment calls. It listens for URLs via .onOpenURL, and both just result in path manipulation, which the navigation stack automatically reflects in the UI.
Okay, so wrapping this up, what's the big takeaway for you, the SwiftUI developer listening? By using this coordinator pattern, adapting it like the article shows, you get much cleaner views because the navigation logic is pulled out.
Right. And you gain really significant advantages in testing that navigation logic and just maintaining the app's flow over time. It's easier to understand, easier to change.
And tricky things like deep linking suddenly feel much more integrated. It's not a separate system bolted on. It plugs right into the coordinator's existing path management.
Yeah, it really feels like a powerful approach for building apps that need to scale or where navigation might get complex down the road. It provides a solid structure.
Definitely. So it centralizes navigation beautifully, which makes me wonder, this pattern is about centralizing a specific cross-cutting concern navigation. What other complex flows or responsibilities in our apps, maybe things beyond just screen-to-screen movement, could benefit from a similar approach?
That's a great question. Maybe complex user flows like onboarding or a multi-step checkout process,
Yeah.
or even managing broader application states like authenticated versus unauthenticated sections of an app.
Yeah, could applying similar ideas, centralizing the logic, separating the concerns, make those areas more manageable too? Something interesting to ponder as you build your next SwiftUI feature or app.